Hello, we're doing 2.3 today for geometry, and that is the Pythagorean Theorem and distance formula. So we're going to start off with the exploration. So if you want to take a second, pause this video and click on the link, type the link, and try this exploration out. Alright, let's take a look at the Pythagorean Theorem. So the hypotenuse of a right triangle. So the hypotenuse is the longest side. I forgot the end. Longest side. And it is a cross from right angle. So right across from here is this C value. Alright, and then we have the Pythagorean theorem. So that's going to be a squared plus b squared equals c squared. So if we take a look at our triangle here, A and B, these are both legs. And then we just talked about C, which is the hypotenuse. So if we square the legs and then add them together, they should equal the hypotenuse squared. So let's go ahead and try a couple of these together. So we have each of our triangles, and for each of these we are given the legs. So we are already given the legs for these problems, which means we'll have a squared, so we'll have 5 squared plus 12 squared equals c squared. So now all we have to do is solve from here. We have to start with our exponents, so 25 plus 144 equals c squared. So before we can add the 5 and the 12 together, we have to square them before we do anything else. So now I have 169 equals c squared. Take the square root of both sides. I now have c equals 13. Okay, now I have number 2. So once again, we're given a and b, which is our legs. So I have a squared plus b squared equals c squared. So 9 plus 16 equals c squared. Now I have 25 equals c squared. Take the square root to get rid of that square. And now 5 equals c. Okay, let's take a look at number 3. So now I have 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. Add 18 equals c squared. So if I take the square root, 18 is not a perfect square, but I can make my factor tree and decide if it is a perfect square or not. So I have 9, or see if we can simplify it any further. So 9 times 2, and 9 is 3 times 3. So I have a pair of 3's and I'm left with 2. So 3 root 2 equals c. Okay, so let's use the Pythagorean theorem to find the length of segment AB in each diagram. So what that means, let me zoom in a little bit. What that means is I'm going to create a triangle. I went a little too far on that bottom one. I'm going to create a triangle, and this is my c value. And then I have a over here and b over here. And it really doesn't matter if a is on the bottom or b. They're both the legs, and we're both squaring them and adding them. So now I just have to count the distance. 1, 2, 3, 4, 5, 6. So this line is 6. Then I have 1, 2, 3, 4, 5, 6, 7, 8. And there's 8. So I now have 6 squared plus 8 squared equals c squared. So 36 plus 64 equals c squared. So I have 100 equals c squared. Once I add those together, take the square root to get rid of my square, so 10 equals c. So the length of this line is 10. Okay, let's take a look at number 5. I create the triangle here. Once again, so we have that right angle, just like we made with number 4 as well. We made that right triangle. So this side is 3, then we have 1, 2, 3, 4, 5, 6 down here, and that's our c, and that's what we're trying to find. So 3 squared plus 6 squared equals c squared. So 9 plus 36 equals c squared. So now we have 45 equals c squared. Once again, when I take the square root, 45 is not a perfect square, so I'm going to go ahead and make my factor tree, which I have 9 times 5, and then 3 times 3. So I have a pair of 3's. So c equals 3 and the square root of 5. So that is the distance from B to A. It's 3 root 5. Okay, so let's go ahead and take a look at the distance formula. So to find the distance between 2 points, or the length of a segment, use this formula. So if I would think about my 2 points, right? Oops. This is what we just had, where we'll have x1 and y1 and x2 and y2. So using those 2 points, I can plug it into my formula and solve for the distance. Instead of using the Pythagorean theorem, I can use the distance formula. So let's go ahead and try a couple of these out. Alright, so this is going to be our first point. This will be our second point. So the distance equals the square root of x2, which is 14, minus x1, which is 6. I'm going to square that whole thing. Plus y2, which is negative 8, minus y1, which is 7. I'm going to take the square of that too. So I have to do everything underneath my radical before I can add them together, or before I can take the radical. So I have 8 squared plus negative 15 squared so we have 64 plus 125. And then take the square root of that whole thing and it'll equal the distance. So now all I have to do is add those together and then we can take the square root. Alright, so D equals the square root of 185.